Hey, what's up, guys? It's Nicola from Calcunic, and today we're going to talk about integrating by parts. Let's get right into it.
So the integration by parts method is a clever trick to take difficult integrals and split them up into simpler ones that are easier to solve. So let's take a look at what we have to do. So we have our integral, and our goal is to split it up into two components. We'll call one component u and the other dv. Basically, the rule states that this integral is equal to u times v minus the integral of v du. Now, the proof of this is actually quite simple, and I'll leave that to the end of the video, but for now, let's just jump into some examples and see how to apply this rule. So let's say we're asked to find the integral of x times e to the x and dx. So right off the bat, there is no clear-cut method to go about solving this problem. So let's try to invoke integration by parts. So our first step is to identify our u and dv. And for this question, let's say that x equals u and that e to the x is equal to dv. So we said that u is equal to x, and we will eventually need to know what du is. So let's do that right now. By taking the derivative of both sides, we get on the left-hand side, du is equal to, well, the derivative of x, that's just 1, and then times dx. On the flip side, we have dv is equal to e to the x, and that's with the derivative with respect to x. And to find out what v is, because we'll need that in two occasions, we will take the integral of both sides. The integral of dv, well, that's just v, and the integral of ex, that's very simple, that's just e to the x. It doesn't change. So now we have all the information necessary. Let's go about solving this problem. So this integral, by the integration by parts rule, is equal to u times v. Well, u is x and v is e to the x, so we write x times e to the x, and then minus the integral of v du. V is e to the x, and du is 1 times dx, so just dx. And so now we'll solve this second integral. We still have x times e to the x minus the integral of e to the x. That's very simple again, that's just e to the x. And of course we add plus c because we are solving indefinite integrals, leaving us with our final answer. So you may be asking yourself, how do we actually go about deciding what part should be u and what part should be dv? Surely there must be some importance, and in fact, this is true. A poor choice for u and dv might even give you a harder integral than what you started with. Thankfully, there's a trick to help you determine which of the terms in the expression you should choose for your u value, and it's called I-late. Basically, this acronym provides a hierarchy of choices for u values, with the highest being the most favorable to the bottom being the least. First off, if you see inverse trigonometric expressions such arc arcsine x or the inverse tangent of x, those would be very good options for u. A close second, and some people even put this above the first one, is logarithms, such as log base 2 of x or ln of x. Next would be your algebraic terms, so that's like 3x or x to the power of 4. Next would be trigonometric operations, which are less favorable, like sine x and cosine x, and least favorable would be exponential expressions, such as 5x or e to the x. Now, this acronym isn't perfect. It won't always give you the right answer, but it is a very good general rule of thumb. The reason for the ordering is because the term we choose for u will eventually be written as du in the final integral. And the types of expressions at the top of the list, so inverse trigonometric, logarithms, and sometimes algebraic, usually have much nicer derivatives to work with. For example, the derivative of ln x is just 1 over x, much simpler than a logarithm. Now let's go ahead and use this acronym to help us solve a few more problems. So now let's say we're asked to find the integral of x times cosine x dx. Now we see that we have an algebraic term in x and a trigonometric one in cosine x. And by the acronym I-late, the algebraic terms comes first. So we will say that u is equal to x in this case. Taking the derivative of both sides will give us du is equal to dx. And then from before we have that dv will be the remaining expression, so cosine x dx, and taking the integral of both sides to get v, we have v is equal to then the integral of cosine x, that's just sine x. So we have v is equal to sine x. Okay, perfect. We have the information we need. Let's start solving this. So by the integration by parts rule, we have that this integral is equal to u times v, or x times sine x, and then minus the integral of v, so sine x, times du, which in this case is just dx. So this is great. We have a much easier integral to solve in sine x than we did with x times cosine x. So let's do that right now. We still have x times sine x, and then minus the integral of sine x, that's just negative cosine x, and then of course plus c for indefinite integrals. And because we have two negatives, that makes it positive. So our final answer is x sine x plus cosine x, and of course plus c for some constant c. All right, moving on. Let's say we're asked to find the integral of arc sine x dx. And if you don't know arc sine x, that's just the inverse of sine of x, or 1 over sine of x. Now, from first glance, this doesn't seem like a candidate for integration by parts, right? Because there's only one term, arc sine x. However, we could notice that this is equal to the integral still of arc sine x, but we'll write times 1 dx, because multiplying by 1 doesn't do anything. So we have 1, an algebraic expression, and we have arc sine x, an inverse trigonometric expression. So that means we will choose arc sine x as our u value. So u is equal to arc sine x. Now, taking the derivative of both sides, we get du is equal to 1 over the square root of 1 minus x squared dx. And just for future reference, this is one of those derivatives that would be very helpful to remember in an exam-like situation. The derivative of arc sine x is just 1 over root 1 minus x squared. And now our other component, we have that dv is equal to 1 dx, so 1 dx. And then by taking the integral of both sides, we get that v is equal to the integral of 1, or just x. And so now we could go about solving this problem. So by the integration by parts rule, this integral is equal to u times v, or x times arc sine x, and then minus the integral of v times du, or just x, over the square root of 1 minus x squared dx. Now you may be telling yourself that it seems kind of like we went backwards. This integral seems only harder than we had before, but actually if we use u substitution, we could get the answer quite easily. If we make this substitution that u is equal to 1 minus x squared, in that case du is equal to minus 2x dx, and by rearranging we could get that dx is equal to negative du over 2x. So using this information, we'll make the substitution. So this integral is then equal to, we'll keep the x in the numerator for now. In the denominator, we have root 1 minus x squared, or by the substitution, root u, and then dx is negative du over 2x. We see that the x's will cancel out, and by taking the constant negative 1 over 2 out of the integral, we're left with the integral of 1 over root u du. So this integral by the power rule is equal to 2 times root u, and then we'll have plus c for some constant c, and then by reducing, the 2's will cancel out as shown here, and that will leave us with only negative root u plus c. And subbing our initial substitution for u equals 1 minus x squared, we have that this integral is equal to negative root 1 minus x squared plus c. And now that we have this, we could put that back into our initial equation. We have that this integral is equal to x times arc sine x. We see that we have two negatives, so that will make a positive, plus the square root of 1 minus x squared plus c. Okay, so now we're asked to find the integral of e to the x times sine x. And by the ILATE acronym, we have that sine x has precedence over the ex term, so therefore we will use sine x as our u value. So we'll say u is equal to sine x, and then we will have du is equal to the derivative of sine, so just cosine x. We have that dv is equal to e to the x dx, and this integral is simple. We say that v is equal to e to the x. And now with this information, we could continue. We say that this integral is equal to u times v, or e to the x sine x, minus the integral of v times du, so e to the x cosine x dx. And so you may be asking yourself, well, we didn't really do that much. We used to have ex sine x, and now we have ex cosine x. It doesn't seem like we accomplished much, but let's try to do integration by parts one more time on this other integral. So once again, cosine x will be our u value by the ILATE acronym. And the derivative of cosine is just negative sine x. And again, we have that dv is equal to e to the x dx, so v is equal to e to the x. All right, so let's use integration by parts. From before, we have e to the x sine x, and then we have minus all of this. We're going to have u times v, so e to the x times cosine x, and this will be minus the integral of v times du. So this is equal to the integral of e to the x times negative sine x. So now what we're going to do is we're going to take this expression and bring it down into the equation, and we'll simplify all of these parentheses. So all of this, we say that the integral e to the x sine x is equal to e to the x, we'll have times sine x, minus e to the x cosine x. And notice we have three negative signs for the integral, meaning that it will be negative, minus the integral of e to the x sine x. And it turns out that we ended up with the same integral we started with. You may be thinking that this was a completely useless process, but actually there's a really neat trick that we could do to solve this problem quickly from here. What we're going to do is take this term and add it to the left-hand side. And notice that both these integrals are the exact same, so we'll just get 2 times that. So we have 2 times the integral of e to the x sine x dx, sorry, I think I missed a few dx's here, just right there, is equal to, by factoring out a term of e to the x times sine x minus cosine x. And all that's left now is just to divide both sides by 2 to give us our final answer. The integral of e to the x sine x is equal to e to the x times sine x minus cosine x, and that's all over 2. So you may be asking yourself, where does this integration by parts rule come from? How did it come to be? Why does it even work? And it all depends on a clever manipulation of the product rule. Let's say we have two functions, u and v, and we're taking the product of them. Their product is equal to the integral of their derivative, because integral and derivative are opposite operations. So if you apply them both, you will just get what's on the inside of them, or in this case, uv. And now what we're going to do is apply the product rule to the inside of the integral. So by the product rule, the inside of the integral is equal to du times v plus u times dv. And then by integration rules on the right-hand side, we have that this is equal to the integral just by swapping the order of these two elements, v times du, and then plus the integral of u dv. And maybe you could see here, all we have to do is move this expression to the other side, and what we're left with is the integral of u dv, and we say that this is equal to uv minus the integral of v du.
Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you made it this far, leave a thumbs up if you liked it, subscribe if you loved it. That's all from me. Till next time.